Most students spend hours rereading their notes and highlighting textbooks, convinced they are studying effectively. But research from cognitive science shows that these two of the most popular study methods are among the least effective techniques ever tested. You are likely wasting enormous amounts of time on strategies that feel productive but barely move the needle on actual learning and retention. That ends today. In the next 10 minutes, you will discover what decades of memory research actually reveals about how the human brain stores and retrieves information. You will learn which techniques consistently outperform traditional studying by hundreds of %, and you will hear about one counterintuitive principle that feels so wrong in the moment that almost nobody sticks with it, yet it is the single most powerful tool for long-term retention that science has ever identified. To understand why most study habits fail, you need to understand something fundamental about human memory. For most of history, people assumed memory worked like a recording device. You expose yourself to information, it gets stored, and you retrieve it later. Schools were built on this assumption. Lectures, reading, rereading, and copying notes all reflect this belief. The more you see something, the more it sticks. That logic feels reasonable. But it is almost entirely wrong. Memory researchers beginning in the late 19th century, most notably Hermann Ebbinghaus, discovered something deeply inconvenient. Ebbinghaus tested himself on thousands of nonsense syllables over years of meticulous experimentation and documented what he called the forgetting curve. Without any reinforcement, people forget roughly 50% of new information within an hour. Within 24 hours, that number climbs to about 70%. Within a week, nearly 80% is gone. Traditional studying, where you read something once or twice before a test, works directly against your brain's natural forgetting tendency and does almost nothing to override it. The real breakthrough came decades later when cognitive psychologists began testing specific interventions against each other in controlled experiments. The results were not subtle. Certain techniques did not just slightly outperform rereading. They outperformed it by factors of 3, 4, and in some cases 6 times, measured by how much information students retained weeks and months after studying. The first and most well-supported technique is called retrieval practice, and it is the most important word in this entire video. Retrieval practice simply means forcing your brain to recall information from memory rather than passively reviewing it. Flashcards are the most common version. Practice tests are another. Closing your notes and writing down everything you remember about a topic is another. The act of struggling to pull information out of your memory actually strengthens the neural pathways associated with that information far more than any amount of rereading ever could. A landmark study published by Roediger and Karpik in 2006 tested students on a passage of text. One group studied it 4 times. Another group studied it once and then took 3 practice tests. 1 week later, the group that only studied once but practiced retrieval retained 50% more information than the group that studied 4 times. Let that sink in. Studying less but testing yourself more produced dramatically better results. This is why practice exams are so powerful, and it explains why students who use flashcard apps consistently outperform those who spend the same amount of time rereading. But here's what nobody talks about. Retrieval practice feels harder and less comfortable than rereading. When you reread your notes, everything feels familiar and your brain sends signals that say you know this material. Psychologists call this the illusion of knowing. You confuse recognition with genuine recall. The moment you close the book and try to retrieve the information independently, you discover how little you actually retained. That uncomfortable feeling of struggling to remember is not a sign you are doing it wrong. It is literally the feeling of your brain building stronger memory. The second major technique is spaced repetition, and it works directly against the forgetting curve Ebbinghaus identified. Instead of cramming all your study time into one session, you spread it across multiple sessions with increasing gaps between them. You might study new material today, review it tomorrow, then again in 3 days, then in a week, then in 2 weeks. Each time you successfully retrieve information just as you are about to forget it, the memory trace becomes significantly stronger. Research by Sapita and colleagues reviewed over 300 studies on spaced practice and found consistent, powerful benefits across all age groups and subject types. Students who used spaced repetition consistently outperformed students who crammed, not just on immediate tests, but especially on tests given weeks or months later. The spacing effect is one of the most replicated findings in all of cognitive psychology, and yet most schools and universities still operate on a cramming model where you study for a week and take one big exam. You can override this by building your own spaced repetition schedule independently of whatever your school demands. The third technique is called interleaving, and this one genuinely surprises people. Most students practice one type of problem until they feel comfortable with it, then move to the next type. This is called blocked practice. It feels very productive because you get better at each problem type quickly within a single session. But interleaving mixes different types of problems or subjects within the same study session, forcing your brain to identify which strategy applies to each problem rather than just executing the same routine repeatedly. A study by Rohrer and Taylor had students practice math problems using either blocked or interleaved practice. During the study sessions, the blocked group performed noticeably better. But on a surprise test a month later, the interleaved group scored over 40% higher. The short-term discomfort of interleaving, the feeling that you are making more mistakes and learning more slowly, is actually the mechanism driving superior long-term retention. Your brain is doing more meaningful work when it has to figure out which approach to apply, not just how to execute one approach it has been repeating all session. The fourth technique is elaborative interrogation combined with self-explanation. Rather than simply reading facts, you constantly ask yourself why and how. Why is this true? How does this connect to what I already know? What would happen if this variable changed? This forces you to integrate new information with existing knowledge, creating richer, more interconnected memory structures that are far easier to retrieve. Studies show this technique boosts retention by up to 40% compared to passive reading when used consistently. Now let us talk about the real-world implications of all this research, because understanding these techniques is useless if the application stays abstract. The single most practical shift you can make immediately is to replace rereading with active recall from this moment forward. After any lecture, any reading, any learning session of any kind, close everything and spend 10 minutes writing down everything you remember. Do not check your notes until you have genuinely tried to retrieve the material. This one habit, applied consistently, will transform your retention more than any other single change. Build a simple spaced repetition system. You do not need expensive software. A stack of index cards organized into daily, weekly, and monthly review piles works perfectly. When you get a card right, move it to a longer interval. When you get it wrong, move it back to daily review. This analog system has produced extraordinary results for language learners, medical students, and professionals studying for licensing exams for decades. Use practice tests aggressively. Whenever you can get your hands on old exams, practice questions, or even just make up questions yourself about the material, use them early and often. Do not save practice tests for the end of your studying. Begin with them. The struggle to answer questions before you feel ready is precisely what builds the deepest memory in coding. Finally, stop multitasking during study sessions. Cognitive load research consistently shows that divided attention during learning dramatically reduces encoding quality. 60 minutes of fully focused study with retrieval practice produces better results than 3 hours of distracted studying with rereading. Your study environment is not separate from your study method. It is part of it. The science is genuinely clear. Retrieval practice, spaced repetition, interleaving, and elaborative interrogation are not marginal improvements. Before you go, if you learned something valuable today, hit that like button right now. Subscribe to Brain Boost Academy for a brand new video every single day. We will see you in the next one.